Hey, have you ever wondered what kind of hardware it takes to make games? Let's find out. Hey Internet, Gordon Ung with PCWorld here with my old friend Will Smith.
Hello.
And we're going to try to answer the question that a lot of budding game developers want to know, and that's what kind of hardware it takes to make games. Behind me is a Falcon Northwest Talon. It is built with...
It's a 64-core Threadripper 7980X. That's a 64-core, 128-thread giant CPU. It's got 128 gigs of registered DDR5 in a quad-channel configuration, so it's a little bit slower than like typical gaming PC memory, but there's more lanes, so more bandwidth theoretically. 4 terabyte PCIe 5 SSD, a Founders Edition GeForce 4090 RTX, and the thing I like the most is that with the Threadripper, it's a bigger CPU, and they actually ship a water block that's big enough to cover the whole CPU instead of just part of the heat spreader. So we configured this machine this way after talking about the workload, which involved a lot of map making and map cooking, big, heavy, high compute tasks. They also offer a lot of pre-configured machines, and you can go into their system configurator and pick out whatever you want. Or if you have questions and don't understand what you're looking at, want to make sure that you're getting the right machine for the work that you do, you can get on the phone and talk to somebody over there, and they'll walk you through the whole thing and help you build a machine that's exactly what you need for the work that you do.
I do want to point out this video is sponsored by Falcon Northwest, but we're free to tell you the truth here, and it's actually pretty eye-opening because you're going to see the performance of a 64-core Threadripper against what a lot of people might consider as you're getting into it, and that is more consumer-based hardware.
Top-of-the-line gaming PC. It's a 14900KS from Intel with 48 gigs of DDR5, 6000 memory, a 2 terabyte PCIe 5 SSD, and it's all paired with an MSI GeForce RTX 4090. In reality, there's no one computer that's the right computer to build games. Like I know people who work on small indie 2D pixel art games that are working on like M1 MacBook Pros, right? Like old mobile hardware at this point.
Okay.
I know people who work on giant workstations. I know people who work on everything in between. In reality, depends on the scale of your studio and what kind of game you're making, what the right hardware is for you. But this all started because I was on the podcast a few months ago talking about doing some of the final work as we were finishing up the Anacrusis, and Kelt Reeves, the CEO of Falcon, was watching and was like, oh, I want to talk to them about making like the kind of computers we make for people who make games, basically, like these big workstations that are built for speed and reliability and specifically tuned for kind of the big workloads that come with making, say, a first-person shooter in Unreal or something like that.
You know, a lot of people know you from being a nerd, seeing you on Tested's YouTube channel, but you actually have game developer background. You're not just simply like me, likes to play with the hardware. You actually did this for a living, right?
Yeah, so in 2015, I left my journalism job and started a VR company. We built VR software for about 5 years. The pandemic killed us, unfortunately. And then I went to work on the Anacrusis with Chet Falasek, who you may know from Left 4 Dead and Portal 2 and Counter-Strike and stuff like that, on his co-op first-person shooter, the Anacrusis, which you can get on Steam right now. So when you're building games, especially shooters, there's a couple of really CPU-dependent, really compute-dependent parts of your workflow. And one of the things that I learned working at a small studio, or both small studios, frankly, is that the time spent when the computer is locked up and you can't do anything else with it is time that you're paying somebody to sit there and do nothing for all intents and purposes. So, there's things like baking light maps, which is where you take all the light sources in the map and all the surfaces in the map and you emit rays and they bounce around and they determine which are the light parts and which are the dark parts of the map. We talk a lot today about like dynamic ray traced lighting that's all happening on the fly, and that's all well and good, but even on a game like Cyberpunk or Fortnite where they have a global illumination model that runs in real time on nice computers, you still have to build those light maps for older consoles and older PCs so that you can sell the game not just to the people who have 4090s and 4080s. So light maps take a really long time to bake. You can run them GPU accelerated, you can run them CPU accelerated. We have benchmarks for both of those. Okay. And then the other big thing is compile times. So compiling is when you take all the kind of package assets that make up the game and you crunch them down and you turn the C code or the C# code or whatever it is you use to make your game into machine code that can run on the computer, and it makes a nice, nice package that's all bundled up and ready to go on Xbox Live or Steam or wherever you get your games or wherever you sell your games. We didn't actually do that as a benchmark because it turns out getting that compile process to run in a repeatable way and setting up on a bunch of different machines is fairly fiddly and time involved. Okay. But the build levels are an incredibly time-consuming part of game development as well, and we wanted to see what we could do to accelerate that.
And you found in your own experience that really is a big time suck.
Yeah, so when we were, so there's two times that it impacts people. When artists are working on a level, anytime they change the position of a physical object that casts a shadow in a level, you have to recompute those light maps. And there's multiple quality settings in Unreal and Unity both for generating those that range from like the fastest we can possibly do it, which on a pretty nice computer is 20 or 30 minutes for a big level, to, hey, we're getting ready to put this on disks and we want to have these as good as they possibly can be and we're never going to change them again, which is a production level. We did both versions of those on my little test map. Now, this test map, which was built with Unreal 5.3.2, is indicative of real-world performance, but it doesn't have as many lights and it doesn't have as many interior areas as like a corridor shooter or a more current game would. So it's indicative of the performance differences you'll see, but it isn't indicative of an actual CPU light bake on, say, a shipping production map in a video game, because I didn't want to have something that was going to run for 8 hours to do the benchmark.
Okay, and what are we seeing on the screen here?
So this is a benchmark that I kind of cobbled together out of some of the default tutorial levels that come with Unreal Engine 5.3.2 rather. So this started out as a shooter benchmark. I added terrain, I put some foliage in, I downloaded some buildings from the asset store, and put a bunch of materials and lights in so that we can kind of simulate in a relatively short period of time the same kind of workloads that happen when you build lights and nav and all of the stuff on a Unreal Engine 5 level.
So your results from your testing between the Threadripper and i9 14900K KS, what are you seeing here? What can you tell us from your testing of it?
Well, so the test, just to be clear, is this: we took this test level, we ran build all levels, which is it builds nav mesh, it builds a lot of the things that are required in the background for the game to work. And basically, anytime you make a significant change to the level, you have to do that. So it's something that an artist is going to do at the end of the day, every day, sometimes multiple times a day, which is pretty time consuming. While it's running, they're not able to work.
Right.
So for that, we saw on the Falcon running at the preview setting, which is the one you would use every day, we saw the Falcon took about 20 minutes to run the benchmark, and the 14900 KS took about 31 minutes to run the same benchmark. So 50% slower or 100% faster, I don't know. You can do the math there. Right. It took 10 minutes, a full 1/3 slower on the
14900.
The 1400 KS.
Although what I'm wondering is like, that doesn't seem as huge a difference as expected. Is this actually test all multi-core? Is it all care about the amount of cores you have?
So that's a really good point. There's a setup process at the start of the light bake. The light bake is fully multi-threaded. It will use as many cores as we've been able to throw at it. When we fire it up on the Threadripper, Task Manager lights up with 128 cores and they're all pegged at 100. The setup process is all pretty single-threaded. So it's usually 5 or 10 minutes, depending on the complexity of the map. It can be more with a more complex map. And that part is going to be single-threaded indefinitely, where the 14900 KS has a pretty significant advantage. Now, the difference is with 24-ish cores between the P and the E cores on the 14900 KS, we see that the Threadripper immediately outpaces it. And by the time the 14900 KS is at like 5%, the Threadripper's almost done. So, it's a situation. Now it's a weird test, because if you really are concerned, if you're having to bake lights a lot, you're probably going to use the GPU accelerated version of the light calculator, which we'll talk about in a minute.
Okay.
When we're in the production setting, which is the kind of thing you do when you're finishing up the game, you're getting ready to send it off to certification, you want to get it ready to publish, and you're presumably not going to work on those levels a whole lot. Like the static geometry of the level is locked in place. The numbers were even more telling. So the difference here is that the light calculations are producing more rays, they're doing more math along the edges, so you get cleaner edges on the shadows, there's fewer artifacts, things like that. And on the Falcon, we saw a runtime of about 25 minutes, usually, between 24 and a half and 25 and a half. And on the 14900 KS, it was about an hour and 8 minutes average time.
Wow.
So, this is the place where having a lot of cores, like the runtime was only 5 minutes more to run production lights on the Threadripper than it was on the preview version, because we have a buttload of cores. On the Threadripper, on the 14900 KS, it was just struggling the whole time and ran for an hour.
It's funny to think 24 cores isn't enough, but it seems like that's definitely where you're going to want the extra cores there.
We've spent a lot of time talking about workloads that will eat as many cores as you throw at them. This is one that has pretty reliably eaten as many cores as I have to throw at it.
Okay. of course, is it realistic will a developer need more CPU cores? Or, if I have a 4090 sitting in my box, isn't that really where I want to do all the work if I can?
Well, so it's a good question. There's benefits to doing the CPU light mattes in that it's generally a little bit, people say that it looks a little bit better. I can't personally see the difference. I'm not particularly sensitive to that kind of artifacting that comes up. And I think as we've gotten further into the GPU compute era, I think the work done on the light mass calculations on the GPU side have been generally better and more reliable than they were in the early days of this. The big question is time, and do you want to put expensive GPUs into all your artist machines, right? If you're going to do GPU compute, you need to have a 2080 as kind of the minimum for the Unreal one. There's a third-party GPU compute add-on that you can use that will work back to 2070s, I believe, but it's pretty memory dependent on the GPU side, so you need a video card with a big chunk of RAM in it. The other benefit of doing it on the CPU is you can share that workload across all the computers in a cluster. So if you have if you have 10 people working on computers with a lot of iron, you can run a background utility on them that will take the work that it doles out in that single-threaded portion and hand a little bit chunk of it out to all the PCs on the network, and that will scale even further than it does with just going to 128 cores, which, like I said, it's a complicated question whether you want a giant big iron workstation or a whole bunch of gaming machines, because there's no right answer. You kind of have to decide what's right for the way you work, the way your team works, and the game you're making.
Okay, so if I'm trying to decide, because I'm starting Gordon's game studio, and I'm speccing out a box, it's significantly more money to buy a Threadripper. I mean, the CPU's $5,000 alone.
Yeah.
How do I decide then? Like, because I probably don't know where I'm going to be going with my game development. Where would I want to bias towards more cores versus more machines?
Well, so it's not always about more cores and more machines too, because when you got to think like a small businessman here, a business person. When you're talking about a machine that is a consumer machine versus a workstation, you're talking about uptime. And now not just the machine breaking and not working, but while I'm baking lights, while I'm doing a compile on my main workstation, I can't do anything else. I can't go work on a different part of the game. I maybe can open up a browser, I can answer emails, I can open up Excel, but realistically, as hard as this hits the CPU in any of these machines, you should just walk away and go make a cup of coffee and come back 45 minutes or an hour in some cases later. And in that case, like if this is my only machine, I'm gonna throw as many cores at it as I can, because 20 minutes versus an hour is a pretty easy decision for me, especially if I'm doing builds more than once a day.
Okay.
Right? If I'm doing my builds at midnight and they go until 3 o'clock in the morning, who cares? It's not while I'm trying to work. But if I want to test something at 11 o'clock and I can't do it until 3 o'clock, that's impacting the amount of time that I have. And if I'm paying people to do that work, it means they're not going to do anything for those 3 hours. And it's money that I'm spending and I'm not getting anything back for. So the real question is, should I buy 2 gaming machines or should I buy 1 giant workstation? And the answer is, it depends on what kind of game you're making.
Right, and again, that comes down to, do you care about those renders locking up your machine for an hour or two? And again, you're just, people are browsing on their phones the whole time. But if they had 2 machines, you can crack the whip and they can do work while doing a render on one of the boxes.
I mean, and maybe the answer is to build a render, a build machine, a build server that does the light maps and the compiles and stuff like that, where you just upload your files to Perforce, the build server downloads them, and you hit the button and it does all the stuff in a closet in the back room someplace. The other thing that I do like about the Falcon is, they've been around for a really long time. They have a pretty well-established support mechanism. Right. They have a 1-day turn where you call them, you have a problem, they either send you a part, you send the machine back to them, they send it back to you the next day, and you'll be back in business in like 3 days, which sounds pretty good to me as somebody who's had a semi-reliable gaming machine that I've had to do a lot of work on, and when it's down, I'm not making money.
Yeah, and that is a classic decision people have to make is, buy versus build. A lot of people sort of assume, oh, I can build it, it's going to be cheaper. That also means you're servicing it yourself, whereas if you have a problem, you call up the vendor who makes it, or if you want to upgrade it, I mean, there are real advantages to it, and again, it is nice to have this. It looks much nicer to me versus that blinky box over there.
It's a little easier to keep quiet. Like the noise level on this is pretty good if I was sitting in an office all day. Now I will say the Threadripper is hot. This machine, when it's under load, pulls 680 something watts, which is a pretty significant chunk of what you can get out of a 120 volt wall outlet in the North America. The 14900KS also 485, 500 watts at load. So it's not an enormous difference there. What I will say is it was really nice when we started down this process, because Kelk was like, hey, I want to do this. What are we going to do? And we sat down and had a conversation about what kind of workloads we're using in Unreal, how we're using the machine, what other stuff we wanted to be able to do with the computer. We talked about gaming, because I wanted to have one computer.
Right.
If I'm buying this for my game studio, I want to have one computer that I play games on at night and I work on during the day. And he was really forthright. He was like, look, you're not going to get the same performance in Fortnite and Helldivers and Call of Duty out of this Threadripper that you will out of the 14900KS.
How much am I giving up then in gaming performance?
Well, so between the 14900KS and the Threadripper, depending on the game. On CPU and memory bound games, it was a lot. Fortnite, we saw a drop from like 180 to 240 frames a second, all the way down to like 110 to 150, depending on which renderer you were using for Fortnite. For Helldivers,
significant hit, but you're still, again, up above the refresh rate of most people's monitors.
Yeah, if you're playing on a 60 hertz monitor, it doesn't matter. If you're playing on a 120 hertz monitor, probably also doesn't matter. Right. If you have a 360 hertz 1080p monitor, maybe we should have a conversation.
Right.
Helldivers, we tried Helldivers 2. It's a little bit of a weird case because it's not a typical engine. It's not Unreal. It's not Unity. It's its own thing. It was a pretty significant hit there too. We were seeing like a fall off from 180 to about 110, 120 frames a second at 4K. So not too shabby, but you're not going to see your competitive Counter-Strike players busting out their Threadripper in the tournaments next year.
Right. No, it hasn't made sense because it's always felt to me like, if I were to describe it, Threadripper versus consumer, even high-end gaming CPU that is basically a consumer pickup truck. This is truly, with Threadripper, you're looking at like a dump truck, like like the ones that you see driving down the road and you don't want to follow because they're throwing gravel out the back. It's a real heavy metal there, which I has a negative because a small pickup truck is cheaper. You can drive it. It's more nimble. But you're dealing with a big, powerful machine with this.
So the one thing I will say is I had a 13900KS in my home machine when we were doing the Anacrusis light bakes. And over the 2 or 3 weeks prior to sending that off for final cert, anytime I wasn't actively working, I was baking one of the 25 or 30 maps in the game. So it was running full CPU for a long time. And eventually it got to a point where I had to crank the multiplier of the CPU down in order to keep it stable because I was hitting it so hard. I've set the Threadripper to just run over and over again for about a week. We haven't seen any degradation. Came back, it was still running. So, there's a benefit of buying workstation hardware, whether it's Threadripper or Xeon or whatever, over your consumer parts. The consumer parts, I think, are probably not designed to run full speed all the time for extended periods of time like you would if you're doing a lot of this kind of work.
No, definitely. Especially, they're really strung out and they are made for very high lighter loads running most of the time at very high clocks, whereas this is basically made to run all cores essentially infinitely, it feels like. So
it's spikes versus endurance, right? The last thing I want to talk about is that the other way to do these light bakes is with the GPU, and is with GPU acceleration. So we did on the Anacrusis, it was an Unreal 4.2.7 game, which is 5.3.2 is the newest version of Unreal 5 as of until like a week and a half ago. Unreal 4.2.7 is probably the last version of Unreal 4. So things that are actually being shipped, games that are actually being shipped, use both of these engines. The difference on perf between 4.27 with the GPU accelerated light bakes on the Threadripper and the 14900K was basically nil, because they have the same GPU. The GPU is the bulk of that performance difference, and we ended up seeing a 49-minute runtime for the Falcon, for the Threadripper, and a 50-minute runtime for the 14900KS. Okay. So, in fact, actually, the 14900KS, the variances were up and down on the 14900KS. Some of the runs were faster than the Falcon. Some were slower than the Falcon.
But that again kind of comes back to what you're saying: is there's no right answer for everything, but there's a right answer for what you're doing. Does it make sense to lean into a 4090 on consumer grade hardware, or do you, as a game developer, go like, you know what, we're on Unreal 4, We're going to be moving to Unreal 5. So I want to look forward and I want to have a little bit of future proofing. So I want more cores with a Threadripper. Does that make sense? Or
It also might depend on who you're who you're buying the machine for. If you're a solo dev and you're making a pixel art game, you probably don't need a Threadripper, right? If you're a 4-person team, you're making a boomer shooter, you're baking a lot of light maps all the time, then one person having a giant Threadripper to be the light bake person is probably not a terrible idea, just because then that person is the one that's out of work, knocked out of work every once in a while, and not all 4 people constantly bouncing stuff around. The other option is, like I said, you buy everybody more reasonable machines, and then you set up a render farm where you have some dedicated machines that are just stashed in an office someplace you don't use very much because it's going to be real hot. And there you put a couple of big Threadrippers in there. Like the right solution for me, the right solution for you, the right solution for Bungie, the right solution for Infinity Ward, they're all going to be different solutions. You have to, this is why having somebody you can pick up the phone and talk to about what you want to do with the computer, I think is really important, especially when you're talking about like indie scale game dev or people who haven't done a lot of game dev work.
So no right answer, but I tell you, it's pretty nice to have 64 cores. What's the right answer for Will Smith's gaming company?
So I'm not actively working. I'm just noodling with some side projects right now and shooting videos over here off and on. The Threadripper is pretty nice. I'm gonna go ahead and tell you, it's having all those cores. I think I'd probably take the hit in game performance when I'm playing games and the ability to like crank out those light maps in like 20 minutes on the CPU and not even have to worry about the GPU.
Right, and I will say it is nice to say you don't have to worry about it because you always know those cores are there when you need them. So
well, and the other thing is when I was having problems with the Intel machine and it was crashing, and I was like, "Hey, Adam, what's going on with this? Do you have any idea?" And everybody's like, "No, I don't know." I'd much rather call Falcon and be like, "Hey, I'm having weird problems with my computer. Can you guys help?" Than be sitting on the Epic forums at 2:00 in the morning cursing because Fortnite crashed every time I tried to play it.
Right, there is something to be said for that service because you can, again, I've dealt with Falcon Northwest for, it feels like 20 years now, and if you have a problem, you get that concierge service, you pack it up, it goes back, it comes back working. So that's always a real nice, especially in a professional environment, to be able to deal with that. So
well, and when we were talking about this, he understood the concerns I had about uptime, right? Like that was the thing that I was pleasantly surprised by. Like when we talk about consumer PC reviews, we're very much bigger, bar better, right? And in this case, he was like, "No, I get that when your computer doesn't work, you're not making money. Let's start from there and then figure out what we can do to make your computer work more," which seems good to me.
Yeah, no, definitely. So, Will, I think one of the big concerns for a small developer or an indie, if I want to start doing games, is cost. We mentioned like you can build multiple machines for the cost of a Threadripper box, because I mean this thing is, again, the CPU is $5,000. I can imagine this thing is easily a double-digit machine or approaches double digits. Can I just write this off as a tax thing? Like, I mean, does that? And what are the other upsides? Because I do want to know, like, if I'm getting into this, because I think I just want to drive down to the store, buy a bunch of parts, screw it together, and I'm going to be good. But there's a real advantage to, again, spending more money on a professionally built machine versus one that I'm going to build myself, right?
So there's two ways to look at it. First off, I'm not an accountant, but my understanding is that every year the accountant is like, "Hey, you need to buy some hardware before the end of the year." And I'm like, "Done, no problem." The real thing for me is the downtime, right? Like if this is a machine that's crucial to me releasing an update or updating the game, fixing a bug, fixing a cheat or a hack or something that's impacting my business, changing the game to address some negative reviews that are causing me a problem, and this machine's down, and I can't release the game without this machine, I like it's the most business emergency I have, and it kind of didn't matter what the machine costs. Now, at the same time, if you're a shade tree developer, you're noodling around with Unreal 5, and you're trying some stuff out, you don't have money coming in attached to this, then it's a different situation, and maybe you're better off, start here and move to there, right? Is kind of the way I'm looking. I think about it. But before we released the Anacrusis, if a build was delayed 3 days, not a big deal. After we released Anacrusis, said, "Hey, there's an update coming at the end of the month," and then we didn't release it at the end of the month, people were upset, and rightly so, because we'd made a promise to them, we didn't live up to the promise. So, keeping your build pipeline going, I think, is really important, especially for indie devs, because you have a contract with the player, and you're saying, hey, we promise we're going to do this stuff if you keep playing the game, and then you don't hold up that your end of the deal, then they stop playing your game.
Right, and there's something to be said for a machine that is probably going to give you 100% uptime versus, again, something that you've built yourself, you're servicing, and they're not going to take like, oh, my machine is broken because of whatever. That is an excuse.
My favorite machine is the one I can put in a back room and never think about, and it just keeps doing what it's supposed to do. And every 6 months, I go out and blow out the fans so that the dust goes away.
Okay. All very good arguments for what to build, what to buy, again, for a game developer. This has been very enlightening, especially this benchmark, because it definitely does seem like more cores helps. For more content on the awesome PC universe, come back to PCWorld's website, PCWorld.com, as well as visiting PCWorld's YouTube site.